Welcome to Module 10, Lesson 2. Our I can statement is, I can use division to determine whether a number is a factor of another number. Okay, so let's take a look at problem 1. Miss Aisha makes a new kind of granola bar for her customers to try. She wants to display 40 bars in equal rows on a tray. Can Miss Aisha place all the bars in 5 equal rows? So if we think about having 5 equal rows, I'm going to zoom in on mine. It's a little hard to see the squares. So we have 1, 2, 3, 4, 5 rows. She wants to display all 40 bars. So I'm going to think 5, 10, 15, 20, 25, 30, 35, 40, 40. Oh, there we go. Can I fit them all? I can. So if I were to draw a visual model, it would look like this. She has 5 rows, and there would be 8 bars on each row. So what shape is our visual model? It's a rectangle. What does the shape tell us about whether or not all the granola bars can be placed in equal rows? Well, what can we tell? Because the rectangle has equal rows, we know she can place the granola bars in equal rows. So we can say because there are equal rows in a rectangle, it shows we can place them in equal rows. Letter C is going to ask us basically to justify that. Can Aisha put all the granola bars in 5 rows? How does your visual model show this? So yes, she can. And how does our visual model show that? It shows 5 rows of 8 bars. There we go. It shows 5 rows of 8 bars. And then letter D asks us, is 5 a factor of 40, and how do we know? So yes, 5 is a factor of 40. A factor times a factor will equal the product. So what is our factor pair here? 5 and 8 are a factor pair. For 40. Right, let's go ahead and take a look at the next one. Miss Aisha has 35 loaves of French bread. She wants to put the same number of loaves in 3 baskets. Can she put all the loaves in the baskets with none left over? So why can we use division to solve this problem? Now remember from the last one, a factor times a factor will equal the product. So what if we think about that using an inverse operation? The product divided by a factor must equal a factor. So if we can divide 35 by 3 evenly, then we know that 3 must be a factor. Go ahead and write your explanation for letter A. If you need more time, pause the video. We're going to go ahead and complete the division now. Pause the video to complete the equation and press play to check your work. You should have gotten the answer as 11 with a remainder of 2. So we need to answer letter C. Can all the loaves be placed in 3 baskets with the same number in each basket? How do you know? Well, can they? No. What will happen? So we will have, there will be how many in each basket? 11 loaves in each basket, but there will be 2 remaining. So now we need to answer, is 3 a factor of 35? So no, it is not a factor. Because 35 divided by 3 is equal to 11, remainder 2. A factor will not have a remainder. So you can say a factor must divide evenly. Okay, so there should be no remainder when you divide a factor. Right, and go ahead and pause the video and complete the check understanding. All right, so you could have used division to check. 51 divided by 3 is equal to 17. 51 divided by 4 is equal to 12 with a remainder of 3. So she should use 3 bins. Your explanation should look something like 4 is not a factor of 31, so it will not divide evenly. Now it's important that you included the word factor because the problem told you to use factors to justify your answer.